Okay, quick introduction. This is CMPS 427. Every semester it's offered. We do group presentations at the end, and this is it. We're going to actually have 3 presentations. This is the first group, and this is WaffleHop, and their game is Gladiator 2. After that, we're going to have the Red Dead Squirrels discussing their game Immortal. And after that, we're going to have the artists. They did so much and worked so hard, they wanted their own presentation, so they're going to show you all the stuff that they did. So that's pretty much it, and I think I'll stay out of it from here and let them have it.
Alright, I'm Philip Marcos, and I'm on Team WaffleHop, and we did Gladiator 2, and that's one of our characters. So the concept is, it's just a first-person shooter, but we wanted a twist. We didn't want it to just be a regular first-person shooter. So we allowed each person to have 2 players. By single key press, you can switch from one player to the other. So you can be attacking, defending. We're hoping that a lot of different strategies can come from being able to play 2 different people. So we're calling this the spooky action. So it's just you're controlling 2 people telepathically. When you die, you respawn. We have weapon upgrades. So if you capture resource points, it gives you coins, and you can upgrade your weapons to make your team better and hopefully win the round faster. We also have turrets and other robots that are just neutral, and they attack whoever they see. The turrets actually will attack the bots, so you can lure them in. So I'm going to talk more about the spooky action. So like I said, it allows for new strategies, but this did come with a lot of challenges because UDK is built to basically have one player controller attached to one pawn, and when you try to attach 2 different things to it, it kind of gets crazy. So we had to go in and do a lot of changing their scripts and building on top of it a lot. And we made it to where you can actually control more than 2 people. We just have a simple array, and it points to all your pawns, and you can switch through them. And this is the other player. We have 2 players, we have a girl and a guy. And when you spawn, you basically have a 50% chance of getting her or the other one, so you can switch between those 2 people. We also added mutators, which you can just change, like gain speed, low gravity, and I have it to where you can control more than 2 people, which gets pretty crazy, but it's pretty. We also did stats and resources. So the UT stats, pretty much they were there for the kill and death ratios and stuff like that. But we added these things called glads, which are the coins that you use to upgrade your weapons. So we had to go in and add those. And this is the resource point. So you basically just stand by the resource point. If you have more than 1 player there, it'll capture it faster. And we just use a simple variable, negative 100 to 100. And if it's in your range, then you've captured it. If you've fully captured the point, then you start earning glads. You get 10 every 5 seconds. And you can use those glads to buy the weapon upgrades. And if you die, you actually lose 50 glads. And the glads are oriented around the team. So if one of your teammates dies, it actually takes off 50 for everybody. It's a pool. So you have to work as a team and not just keep dying. People are getting mad at it. So to take care of the resource points and showing them on the screen, we made our own HUD, and Joy's going to talk about that.
Hi. So there were 2 ways that UDK allows you to do the HUD, and the way that I originally planned to do it was with Flash, but we found we didn't have the program. So then I decided to try Canvas. However, Canvas is a lot harder to use, and there's less resources available because UDK builds their system around using Flash and scale form. There are issues with extending it because in Flash they use certain classes to extend from, and because of those issues we weren't able to use the scoreboard. I was able to get that working with our Canvas HUD, but there were still issues with viewpoint. It wouldn't, whenever you maximize the screen and such, it didn't actually move the HUD, the health bar, and the ammo and such down to the bottom in like the position that it was before. Crosshair didn't appear. At first, the ammo wasn't being called correctly, and images were just being difficult. And as you can see the picture, that was like one of the first iterations of the canvas HUD, and just very simple, very basic, has used rectangles for showing it, and faded them out whenever they weren't actually there, or whenever you used the resources there. Then we moved on to using Flash, which is a lot easier. It's what UDK wants people to use now. It fixed almost pretty much all the issues that we were having before with Canvas. It has there are a lot more tutorials and such on it. The crosshairs show up. Scoreboard didn't have any problems. That actually was just no problems at all, because we're actually able to use the classes that UDK wants you to use whenever you for the HUD and such to show the scoreboard, because they wanted you to use the that you use Flash with. And we also created a menu, which you'll see when we play the game. And this is like one of the first iterations of the Flash HUD. You'll see the updated one whenever we demo the game. Next we will have Nick, who will be talking to us about the AI that we use in the game.
Okay, so originally we had planned to use bears, but we felt that the synthetic model would be more conducive to the storyline. And we also had some issues with player roaming, but I will get to that. When I started AI, I really didn't have much experience with it. It was the first time I'd ever used it. And one of the first things you have to do, of course, is describe, well, how do you expect them to behave? And I had decided that they were not going to be aggressive. And in fact, as we'll see in the game later on, if you don't bother them, they tend to go about their own business. Afterward, I tried to use a different type of spawning mechanism to spawn the bears during gameplay, but that wasn't conducive to gameplay either. So instead, I decided that I would use a list where every 10 seconds or so, the spawner checks to see how many bears are in play at a given time. And if there are less than, I think the limit is 2, then another bear will be spawned. Another problem I came across was navigation. Originally, I had planned to use the waypoint system, which is available in UDK, but I found that they do not, or UDK does not allow the waypoint system to move very naturally. Instead, we had to switch to the navigation system, which allows for natural movement. Next one. Going back to the AI controller, we can see with use of the state machine here exactly how the AI behaves. It begins in the idle state, and if it does not see a player, it will remain there. In the event that it sees a player, the navigation mesh will use a point and generate a path from where the player currently is to the bear. And that path is then loaded into the cache, and the cache then will provide the AI with another point at each iteration. Once it reaches the player, the AI will move into the attacking state. And of course, if the player destination changes, it removes itself and goes back into the following state. And of course, if the player dies, it returns to the idle state. Next slide. This is the waypoint system. As you might be able to see based on the screenshot, you place the apples and the player's start point, and UDK will automatically generate linear paths between the the player spawn and the path middles. Next slide, please. This, in contrast, is the navigation mesh system. One place is a pylon, and the game will then generate a traversable area denoted by the green area in the map, and the red area, of course, is impassable. Looking forward, I'd like to have the bears respond differently to damage, and I'd also like to implement a roaming system, which I had an algorithm for, but I felt that the game did not require that in order to be cohesive. In conclusion, I felt that this was a very good experience. I certainly learned a lot about AI that I didn't know. And I think that Patrick's going to talk about turrets now.
So I'm Patrick. I designed the turret system, and a lot like Nick's AI, mine can be modeled using a state machine. And so essentially it has 4 states, and it starts out in an idle state, and this is basically where the turret waits around and it scans for targets. And then once the turret has a pawn is basically any movable or moving controlled object in UDK. This can get targeted by the turret, and whenever one comes within its radius, say 1,200 UDK units, then it'll start to attack this unit. And from here, this transitions from, and so the alert state is whenever it finds the target, and then it transitions to the defense state, which is basically where it starts to actually shoot projectiles at the target. And from here, it just keeps shooting the target until it gets out of range or until the player destroys the turret, in which case, if they would destroy the turret, then it would go into the dead state, which is the final state. And but this actually isn't the end, because after the dead state, if a player is close enough to the turret, he can actually repair the turret, and it'll bring it back to life and go back to the idle state, waiting for another target to be acquired. And so basically, a lot of problems that I had ran into initially involved Euler angles, which are essentially vectors which model orientation for objects in UDK. So a lot of times this is modeled using the roll, pitch, and yaw. It's what they're called. And a lot of times there's an analogy using planes, in that you have a plane, like in this diagram, where its roll moves like this, and the pitch, it goes forward, and the yaw is whenever it rotates about the y. So basically each vector component of Euler, or each Euler angle, is a rotation relative to a certain axis, be it the x, y, or z axis. And so you can think of the turret as it has its barrel out like this, and so this would be the yaw, the pitch, and the roll, going back and forth. And the most important one, obviously, would be the yaw, because you want it to follow a certain player. Unless they had jumped up, then maybe the pitch would come into play. But for the most part, you really need the yaw to do most of the job. And at first, I had problems with the skeletal mesh, which is the, basically the model for the turret. And essentially, the Euler angles were reversed. And so anytime a character would move, it would move in the right number of units, but it would only move relative to the z-axis, well, on the pitch, I mean. And, but it needed to move according to the yaw, and instead it was moving on the pitch. So after a long time of trying to figure out what programming problems I had wrong, turned out in the end it was really just a problem with the mesh. And this was a mesh that I had gotten off of the internet, so I guess there are obvious problems with that. So currently there are also passive turrets, which act as scanners. They don't actually attack the players, but hopefully in the future we'll be able to implement movable turrets and things like this. At the moment, we just have the passive turrets which stay there, and the active turrets, I guess you could call them, which attack players and work on the state machine that I mentioned earlier. And as I mentioned earlier, you can repair turrets. So basically when you press the R button, it'll bring the turret back to life. And one of the big problems we had in trying to get this working, not just locally, but on the server, was one of our big issues in trying to resuscitate the turret while in a multiplayer game. And I'm going to let Ross explain more of that since he's our networking expert.